5.5 Properties of logarithms. In this section, we are going to learn use the property of logarithms to simplify expressions and use the change of base formula to solve the logarithm expression. Property of logarithms. If b is a positive number and your b cannot equal 1, then the log base b of 1 is equal to 0. The second property is log base b of b is equal to 1 because your log base b is equal. We can reduce with b 10 to the 1. So when you have the b of log base b, these two, they can be reduced. Or the other way around, when you have log base b of b, they can be reduced as well. So 10 to the 1. The third property, log base b of b, so here they can be reduced and you 10 to the x. The next one, b, the base b of the log base bx. Same way, this b can be reduced of the log base b. So it still has x only left. So equal x. And keep in mind, this x must greater than 0. We don't take the log base b with a negative x value. This is undefined. Okay. So make sure that the part of your x term, your x term logarithm form must be a positive number. We do the practice here. Simplify each expression. Log base 3 of 1. So if I treat this expression as a box on the right hand side, that means convert into the exponential form, we will get a 3 to the power box equal 1. So apparently the box number must be 0. Part B, log base 4 of 4. So since this 4 can be reduced with the log base 4, so it just simply equal 1. Log base 7 of 7 to the power 3. Again, log base 7 and the 7 can be reduced. So it turns to the 1. And then you use a 1 to multiply 3. It turns to a 3. B to the power of log base b of 3. Same way, b log b, they can be reduced 10 to the 1. So it has 3. Again, log base b of b, you can reduce. Or b to the power log base b can be reduced as well. Okay, so they'll 10 to the 1, 10 to the 1. Alright, so we do the practice here. Alright, so now we move on to the logarithm property of the product rule and the differences rule. If n and b, they're all positive number, your b not equal 1, then log base b m multiplied by n, we can expand into log base b of m plus log base b of m. So you convert a single logarithm, right? This one, you only have single logarithm. It turns to a 2 individual logarithm. We call extend. You extend the logarithm form. The next property we call the quotient rule. The quotient rule has a log base b, use the m, divide by n. You have a single logarithm form. Now we extend then into the 2 individual logarithm form. it turns to the log base b of n to minus log base b of n. We call this as a quotient rule, and this property we call it the product rule. There's one more rule we call log base b of m to the power p. We can swim this p to the front of the logarithm term. So it turns to the p multiply log base b of m. We call this as a power rule. There's one more rule here. If the log base b of x is equal to log base b of y, since the log base b, they are equivalent, so we can just cross out the log base b on both sides and then let the x equal y. We call this as a one-to-one property. This one-to-one property, you also can use that for the exponential form. When you have the b to the power x equal to b to the power y, we cross out the base b and let the x equal y. Now we do some practice from your homework question. Find the value of x. The equation gives us x to the power log base 5 of 4 is equal to 4. So that means this number, x value, must have the same base number from the logarithm, and then they cross out so that you will get a 4 by the end. So apparently the x value must be 5. Assume x, y, and b are positive number, b not equal 1. Use the properties of logarithm to write the expression in terms of the logarithms of x and y. So we need to apply with the logarithm property to expand this expression. So the first thing I can see here, it has a square root sign. So I'm going to rewrite the square root sign into the degree power form. So I copy down the log base b, x, y, it turns to the power half, because the square root sign is the same meaning as the degree power half. Now we have the degree power, so we go with the power rule. According to the power rule property, we can swim the power number to the front of the x term. So it turns to the half multiply log base b x, y. Now, with the log base b x and y, we go with the product rule. So we can expand a single logarithm into the two individual logarithms. Half, we treat a half as a common factor. So now I'm going to rewrite the log base b x plus log base b of y. And then you stop it here. Use the change of base formula. If a, b, and x are positive, b is not equal 1, a is not equal 1, then when you have the log base b of x, you can rewrite it into the log base a of x divided by log base a of b. Or you can rewrite it into just the log of x divided by log b. With this form, there is no base number. The mean is 10. But when you use a calculate, you don't need to type in the base 10. You can just simply type in log of x divided by log of b. For example, you have the log 7, 2. If you calculate, you don't have the change base rule, can input the number into it. You can just simply type out log of 2 divided by log of 7, and then it will give you the same value when you type in the log base 7 of 2. We call change base rule. Use the change of base formula to find the log base 3 of 5. So you can just simply to type out log of 5 to divide by log of 3. And you will get the right answer. We do another 2 question here. Assume x, y, z, and b are positive number. B is not equal 1. Use the property of logarithm to rewrite this logarithm form. This single logarithm has a quotient rule here, so we use a quotient rule property to rewrite. So we start to expand. I keep saying extend. Sorry, expand the single log into 2 individual logarithms. So we have the base b. The numerator turn to the first term x. Now you minus another log with base b. You copy down the denominator part as y times z, because we have the simplest form, log base b of x. So now the second term here, we have log base b of yz. We have to continue to expand it by using the product property. So I write down the minus sign here. I use a parenthesis to run it. Now the first term, we will have the log base b of y plus log base b of z. Close it. Now remove the parenthesis here. So you have the log base b of x minus log base b of y, then minus log base b of z. And you complete the work. You have expanded a single logarithm into 3 individual logarithms.